Hi, my name is Christopher Jones, and in this short video I want to talk about the interplay between requirements, the behavior model, and the CATIA CAD model. To that end, we have this excavator model, and a whole host of requirements are associated with this. Amongst those requirements, we have thermal requirements in regards to the maximum cabin temperature, which should be under 307 Kelvin. Now, in the logical architecture of our system, we can navigate into the system's architecture and look at our air conditioning system, which has a behavior model associated with it. We can load this, and we can see that our behavior model contains a secondary loop system, which is intended to cool the cabin of our excavator. Within the various components, we'll see that the geometric parameters of our system are all fully parameterized, and these are exposed to knowledgeware. We can tell this by the small icon with the graduation hat. Now, if we run this simulation, we can, of course, look at all the individual simulation results for the different components of our air conditioning system. And amongst those, we have the cabin temperature, which we can plot, and we see we're above the 307 Kelvin threshold. This is also visible in our analysis view, where we see various requirements associated with our system and whether they're fulfilled or not. The cabin temperature, you can tell, is above the requirement threshold and therefore not fulfilled. Now, typically when an engineer is scaling the air conditioning system, they would be running dozens or maybe even hundreds of simulations to narrow down the parameters and settings of the system. And assuming we've done that, we might come to the conclusion in order to fulfill our thermal requirements, we have to increase the size of our heat exchanger. So we might have to change the number of plates within the heat exchanger. This we would then communicate with whomever is the owner of the requirements and make a change request in order to agree on this change with all the stakeholders. Once we've done that, whoever owns the requirements might change certain requirement parameters that are used throughout the system, such as the number of plates. So we would change that from the current 50 plates to 100 plates. Now, in the parameters of our system, we'll see that our values aren't updated. So we want to use the update functionality of the 3D Experience platform to perform a local update in order to get the up-to-date values from the underlying database. And now we see the number of plates has increased to 100 as we said previously. And now we could execute our model again. And in the simulation results, we'll plot the cabin temperature with the updated number of plates. And we can also plot the old cabin temperature with just 50 plates in the same window to compare. And now we can see the cabin temperature has clearly dropped, and the maximum cabin temperature with 100 plates in the heat exchanger is below the threshold. Back in our logical architecture, we can check the results analysis again, and we'll see the cabin temperature requirement is now fulfilled. We're under the threshold that we defined, but we can see that the height of all the installations on the back of the excavator is now too high, and we break a different requirement that we've set. This will also be reflected in the CAD model. If we zoom in, we can see the air conditioning system here, this block at the top. And if we update the CAD geometry, which is parameterized using the same parameters that we use in the behavior model, we'll see that the air conditioning system on top of our excavator is now significantly higher, and this is conflicting with certain other geometric requirements that we might have set. So the overall height is too high. With that, we would now then have to go back to the drawing board. Instead of making our air conditioning system higher, we can make it wider to achieve the same cooling behavior, but still fulfilling the geometric requirements. With that, we can see the interplay between requirements and requirement parameters that we define, which influence the system's model and the CAD geometry. Thank you.